Welcome to another video solution by Kode. In this video, we will be looking at the longest substring without repeating characters problem on LeetCode, and this video will provide you with the C++ solution of this problem. I have also made a video for the Python solution of this problem, and if you are more comfortable with Python, then you can go ahead and find that video linked in the description box. So, without wasting any time, let's proceed to this problem. In this problem we are given a string which can consist of letters of the English alphabets, digits, symbols and spaces. We need to find the longest substring in the input string which has no repeating characters. In other words, we need to find the length of that particular substring in the input string, which, number 1, has only unique characters in it, and number 2, is of the maximum length possible. Just for your understanding, I'll also tell you what is a substring. A substring is nothing but a continuous set of characters in a string. So if you see the first example, the first 3 characters, that is, A, B and C, are a substring of the input string S. But the characters B and not a substring because they are not continuous in the original string. Now to understand the problem better, let's check out the input sample 1. In this example, the substring ABC is a substring of unique characters and has length 3. The substring BC and A is also a substring of unique characters and has a length of 3. Note that the substring A, B, C, A is not a substring of unique characters as there is the character A is being repeated. As there is no other substring of length greater than 3 and having unique characters as well, the output to the function will be 3. Now, let's check out the second input example. Here, all the characters in the input string are same. This means that we can't form any substring of length greater than 2 which also has unique characters. Thus the output to this example is 1. Now, having understood the problem, let's head over to the Python code to solve this problem. The technique that we are going to use here is called a two-pointer technique. The basic idea is that while iterating over the input sequence, we are going to check what was the latest occurrence of that particular character we are currently at in the input string. Now there are 2 possibilities. First, we might have never seen that particular character previously. This means that the current character can be considered as an addition to the current unique character substring window. The second possibility is that we might have seen that particular character previously while iterating over the sequence. In the second possibility, there are further 2 more cases possible. The current character has another occurrence in the current unique character window, and the current character does not have another occurrence in the current window. Let's understand the solution line by line and understand what exactly we are doing. First, we have defined 2 pointers, left and right, which are going to store the start and the end index of the current unique character window, and we are going to play over these pointers in such a way that the characters lying between these indexes always form a unique character substring. After that, we define a map which will store the latest occurrence or the index of a particular character in the string it was last observed. So we start with our while loop and constrain the left and the right pointers to stay within the range of index possible. Now, the first case comes. The current character, that is, S of right, was never seen previously. This means that the S of right can be added to my current window of unique characters. With this, we add an entry in the last seen dictionary with the index of S of right, which is right itself. The second case is that S of right has already been seen before while iterating over the string. Now if you recall, we said that we are going to manage left and right pointer in such a way that the characters between these indices are always unique. This means that my current unique character window begins at the left index. So, if the current character was last seen at an index more than the start index of the current window, this means we cannot include the current character in the unique character window. You can also understand this with the help of this diagram. So if the last seen location of S of right was to ahead of the left pointer, we just update the current window and now bring our start of the unique character window to the last occurrence of the current character +1, right next to the last occurrence of S of right. Now, as we know that the characters between the left and the right index are all unique, we just update our current result with the max of the current result and the length of current unique character window. Along with this, we also update the last seen of S of right with right and move to the next character to check if the next character could be included in the current window or not. Finally, we return the value stored in result. That is it. Great job, and we are done with the solution. Let's try to run it and see if it works or not. And there you go. The solution has been accepted. I hope you liked the solution. If you did, then please hit the like button and press the bell icon to stay updated about the latest problems and their solution on LeetCode. Bye for now. Happy coding, and I'll see you next time with another exciting problem and its solution.